Hi and welcome to this section where we would like to look at the Lagrange interpolation. So in here, in this very elegant and powerful interpolation technique, we would say that given points x0, x1 and x0, x1 and so on up to xn, okay, we would like to define the cardinal functions L0, L1, L2 and so on up to Ln, okay, which are polynomials of degree n, satisfying this relation that Li of xj equals to a Chronicle delta function. This is called a Chronicle delta function, and it is a function such that it takes on the value 1 when I equals to j, and it takes on the value 0 when I is not equal to j. Okay, yeah, there is some quite serious implication about this. They call these functions, they are functions which have local support, okay, in numerical analysis, but I beg not to go in details of this functions with local support which are locally supported on a given interval and so on. Let us take it that these L nodes here have to satisfy this important property of taking on the value 1 when I is equals to j and 0 when I is not equal to j. In addition, we would like to define Li of x to be the product, okay, this pi here, this big pi here means the product, okay, the product from j equals to 0 up to n excluding j equals to I. Okay, so we say that j is not equal to I. We sum from j equals to 0 up to n excluding the point j is equals to I of this quotient here, x minus xj divided by xi minus xj. So this product here, we can try to expand it here and write it out. Okay, so if we try to expand it, we can say that this is going to be equal to we can start the product here. Let's see, we can now start by saying we have x minus x naught, okay, then next we can have the product now x minus x1, okay, j is 1, then x minus x2 and so on and so on and so on, alright, until we reach the point x minus xi minus 1, okay. Of course the next point after this would be x times what? X minus xi, because this is xi minus 1. However, remember we say that j is not equal to I. This value of j does not take on the value I. That means we skip this value and go to the next value, okay, which is x minus xi plus 1, and then we go on multiplying until we get to x, until j takes on n, okay. So this is what we have in the numerator, and then everything here we divide by the product in the denominator, which is exactly the same thing, of course excluding I is equals to j, and definitely when I is equals to j it makes no sense because that would run to 0 and you cannot have your denominator running to 0. So we simply write down the same thing, and which is xi, okay, remember here we have Li of x, okay, so we have xi minus x naught, then we have xi minus x1. We are writing exactly what we have up there, but we are replacing the x with the xi, so minus x2 and so on, xi minus xi minus 1, okay. Of course xi is not equal to xi, I mean we skip the point j is equals to I, because there I would have xi minus xi, which would make the denominator run to 0. But we know that j will skip that value of j is equals to I, and we'll take on the next value, xi plus 1. So we take this product until the very last one. This is xi minus xj when j is equals to n. That is the very last value. So this is our product for li of x using this. And of course, we know we have this important property that li, okay, of xi equals to 1. Actually, we can check that li of xi, in other words, when x is xi, okay, when x is xi here, when x is xi, in other words, when x is xi, definitely you see that whatever you have is going to be 1. Everything we have 1, yeah, everything is just going to be 1 1 1 1 1. Okay, all right, but I will remove that so that I do not confuse any people here. Okay, so we have this important property that li of xi equals to 1. Okay, and what else? We know that li of xk is equals to what? To 0 when I is not equal to j. Okay, great. So what next? Now that's all we need. We can now work out a problem here. Let me get a problem. I didn't write the problem here. No, before even we get to the problem, we have to write the Lagrange form. The Lagrange form. So the Lagrange form takes on the following. So our polynomial of degree x, okay, can be written as the summation from I equals to 0 up to n of li of x times yi, okay, which can simply expand when we start now summing from I is equals to 0 up to n. So we have L naught of x times y naught plus L1 of x times y1 plus L2 of x times y2 plus and so on until we have Ln of x times yn. Okay, yes, so we would like to look at an example here and see. So the example we have here is that we have a table with values given to us, and we would like to have a polynomial of degree 2. Remember, we said that if we have three data points, then we can actually have a polynomial of degree 2 or less. Okay, so we would like to use the information given to us in the following table. And what information is given to us? We have the values of x, okay. In this column here we have 0, we have 2/3. I should have added another column here, and some other rows. So we have 2/3, and then we have 1. And then what do we have here? We have yi, which is equals to yi, of course we know yi, but we know yi is equals to f of xi. Okay, so no need to write that. But y takes on the value 1, takes on the value 0.5, and it takes on the value 0. So okay, that's all we need. And so we would like to find a polynomial of degree 2. So if we want a polynomial of degree 2, that means that we are going to set our n to be equal to 2. Okay, so we want p2 of x. Okay, so for p2 of x, that means that we are going to sum from I is equals to 0 up to 2 of li of x times yi. When I is 0, we are going to have L0 of x times y0. Then when I is 1, we shall have L1 of that times y1. And then when L is 2, okay, we shall have L2 of x times y2. So we have to find this L0, L1, and L2. Okay, so to find L0 of x, we are simply going to substitute here. How do we find L0 of x? Remember, we just wrote down our form for Li of x. What is Li of x? It is this product here. Okay, so we are going to say that okay, maybe we can start by reminding ourselves here. We say Li of x is given as the product from j equals to 0 up to n, and we exclude, okay, we exclude the point j equals to I. Okay, we don't take it, of this quotient here, x minus xj divided by xi minus xj. Okay, so if we have that, we can now say L0 of x is simply going to be the product of what? From j equals to 0 up to 2. Remember, we are looking for our n is 2 because we have a polynomial of degree 2, and we know that our j is not going to take on the I value here, which is 0. Okay, remember, this is L0 of x in this position. I mean, in the form, the general form is Li of x. So if we have L0 of x, that means that j is not taking on the value I here, which is represented by the 0 here. So we exclude j is equals to 0, x minus xj divided by xi minus xj. So what is this product here? So we know it is going to be x. Of course, j is not equals to 0, so it will start at x1. Okay, and then the next is going to be x minus x2. Okay, remember, we have the points x0, x1, and x2. Okay, this is y0, this is y1, and this is y2. So we have x minus x1 times x minus x2, and then we say that in here it is just the same. We are just replacing the x with the xi. Okay, and this is xi minus x2, but in which xi, remember, our I here is 0. Okay, so in other words, here we are going to say x0, and this is x0 minus x2. So the rest is just now substituting. Well, we want to find the polynomial of degree n, so we don't know yet that, but we know the value of x1. x1 is 2/3, and then into x minus x2, x2 is 1, and then everything here divided by x0 is 0 from the table, then minus 2/3, and then here we have 0 minus 1. So we know This is negative 2/3 and negative 1. That will give us, we are dividing everything by 2/3, so we shall have 3/2 here into x minus 2/3 into x minus 1. You can please check for any mistakes made. Okay, so similarly we shall use the same way we have done to find L1 of x. Now L1 of x, we don't need, I just wrote this one here since we are doing this for the first time, but for now you can notice that L1 of x, we are going to write x minus, we are simply going to exclude x1. Okay, we simply exclude the point, yes, x1 here. So we shall write x minus x naught, x minus x2, divide by x1 minus x naught, and then this is x1 minus x2. Okay, so you can substitute these values here, x minus x naught, so we have x minus x naught is 0, then x minus x2, which is 2/3, oh no, 2/3 is 1, I mean x2 is 1. Okay, and then divide by x1, which is 2/3, minus x naught, which is 0, and then this is 2/3 minus 1. Okay, so you can please check it out and verify that you get 9 out of 2 x into x minus 1. So I'll just write here the formula for L2 of x. Okay, so for L2 of x, we simply exclude x2 in the numerator. Okay, so we have x minus x naught, and then we shall have x minus x1, and then in the denominator we shall have x2 minus x naught, and then we shall have x2 minus x1. Okay, so please fill in this, and you make sure, if this may be wrong, I may have made an error. Okay, and that you get that. Okay, and then now we just come and substitute in our formula here, p2 of x, which we said is L0 y0, L1 y1, L2 y2, and then when we substitute L2, I mean L0, we found out that it was given as this, and then we multiply, it was into this, then y0 is 1, the value of y0 is 1, so we have times 1. Okay, and then what else, then plus, then this other one we got what is it, we have 1/2, okay, into negative 9 out of 2, we have x into x minus 1. Okay, and then the other value is a 0, so this is the L1, which is this one here, negative 9 out of 2x into x minus 1. Then this 1/2, okay, is that the value of y1? Let's see, y1, yes, y1 is 0.5, okay, which is this 1/2 here. So that is how we can use Lagrangian. Okay, of course this is not the end here, but I've run out of space. You can now simplify. You can simplify this expression and then come up with an equation which is a polynomial of degree 2 using this Lagrange interpolation. Okay, it's quite a powerful method. We shall look at further examples later on, or even you can check in the textbook. Okay, and yes, for now we can stop here, and then if there is any question or any comment, you can please put it in the comment section. I hope this can be easy for you to follow. Thank you, and see you in the next video.